Hello students, moving on to the next topic in computer graphics, that is general three-dimensional rotations. A rotation matrix for any axis that does not coincide with the coordinate axis can be set up as a composite transformation, so involving the combinations of translation and the coordinate axis rotation. Following transformation sequence is used. Here is the here is an example. Original position of the object, as you can see, and rotated object, that is diagram C, diagram 1, but A as well as C. Before that we have one more diagram. Translate the rotation axis onto x axis, right? The meaning is, earlier we have discussed about the pivot point rotation, recall that. So rotation is allowed from the origin as per the 2D rotation, as per the discussions we have conducted with respect to the 2D model, right? So for that, what we did, we have performed the composite transformation. First we have translated the object to the origin, then we have rotated it, we have retranslated the object back to the original position. So similarly here you have to consider the reference axis. It can be x axis, y axis, or it can be even z axis. So in the diagram number 1, the rotation axis, which is just observe the statement, rotation matrix of any axis that does not coincide with the coordinate axis. The rotation axis is the different rotation axis is taken which is parallel to x axis, but it is not exactly on the x axis, isn't it? So your job is to keep it on or place it onto the x axis, perform the rotation and translate it back to the initial position of the rotation axis. That's it. So your job is what? First step, you have to place it on top of the particular axis, right? Go for rotation, then retranslate it back to the initial stage or initial state. So this is what the diagram or sequence of diagrams you can find. In diagram A is the original position of the object, and in diagram B, what we did, we have translated it onto the x-axis, right? Translated it onto the x-axis. Translation is done here. Once the translation is done, you are allowed to perform the rotation on top of the particular axis, any of the axis it can be. So we have kept it on the x-axis. Go for x-axis rotation. You can see the diagram C. Diagram C, see, rotation angle is theta. From here to here the model is rotated, isn't it? Then diagram number D, so translation back to the, translate this object, see the position of the object, it is to be kept on top of the rotation axis, right? Check the pointer, in this position it is to be kept, so you have to go for translation. Here translation is done, it is kept on the rotation axis, so it is kept on to the initial position, right? The steps are given here. You can go through the description. Translation is the first step, then perform the specified rotation about the axis is the second step, and translate the object so that the rotation axis is moved back to the original position, step number 3, right? So let us see the equation, how to write the equation. A coordinate position P is transformed with a sequence shown in the in this figure, the above figure, what we have discussed, the sequence, right? So P dash is the new point. How P dash or new point is derived? So set of transformation, actually we have performed rotation, right? It is a rotation along with x-axis, in general rotation along with x-axis in multiplication with theta, in multiplication with the original point P. So rotation along with x-axis of theta in multiplication with original point P, isn't it? But what is the meaning of Rx of theta? Observe carefully the above diagram. You have performed the sequence of steps. What are the sequence of steps you have performed? See, first you have performed the translation, isn't it? You have performed the translation towards so what, top to bottom, isn't it? As per the diagram I am speaking about. Then you have performed the rotation, then you have retranslated it to the original position, that is bottom position to the top portion. So the sequence of steps can be marked as follows. First, what is done? See here, T inverse, even you can write a T on, not an issue. So inverse translation matrix is mentioned first, followed by rotation Rx of theta is mentioned. Then what is done? retranslation. So first is inverse translation taken, that's why now you have to take the opposite of that, t inverse of inverse, that will become t only, in multiplication with original point p. So you can find the sequence of steps here. What are the sequence of steps you are supposed to perform? So it is not just a rotation, this prior to the rotation you have performed the translation. So translation towards left or top to bottom negative values you have added, right? So inverse translation you mark it as t inverse. Then after performing rotation you have added the values, so mark it as t. So t inverse in multiplication with rx of theta you can find in multiplication with t, so in multiplication with p. Okay, the entire term, that is what I have marked in the box, see this box, t inverse in multiplication with r or rx of theta in multiplication with t can be written as, say, r of theta in general. That is for the substitution purpose or the simplification purpose. Okay, when an object is to be rotated about an axis that is not parallel to one of the coordinate axes, we must perform some additional transformations. We can accomplish the required rotation in 5 steps. See here, when an object is not rotated about an axis that is not parallel to one of the coordinate. Earlier we have considered the object was parallel to the x coordinate, right? So if the object is not parallel to any of the coordinate, neither x nor y nor even z coordinate, in that cases there are some additional steps you have to perform. Total number of steps will become 5. Just go through these 5 points. So translate the object so that the rotation axis passes through the coordinate origin. Remember the points or note down the points. Then rotate the object. First is translation, of course. Then rotate the object so that the axis of rotation coincide with one of the coordinate axis. Then go for perform the specified rotation about the selected coordinate axis. Then apply the inverse rotation to bring the rotation axis back to the original orientation. So additional steps of rotation to be ignored. That means inverse rotation you have to perform. Apply the inverse translation, right? This is must to bring the rotation axis about its original spatial position. So as you can see the diagram here, initial position of the point P1, P2, we have considered the line segment as well. Okay, initial position, check the straight line, it is not parallel to any of the coordinate axis. So what we did, in the first step we have translated this particular line segment onto the origin, as you can see over there. So the new values of the points are marked there as P1 dash to P2 dash. Then rotation is done. So rotation of P2 dash onto which axis? No, along with z axis is taken. Check the position, you will come to know. So along with z axis rotation is taken. Next what we did, rotate the object around the entire object around the z axis. Then rotate the axis to its original orientation. As you can see, this will become similar to step 1. Then finally the 5th step we have to translate it back to the initial position. So these are the sequence of steps we are performing in case if the object is not parallel to any of the coordinate axis, any of the axis like x, y or z. Okay, so just go through these steps once, note down the contents. These equations are very important. If you have any doubt, you ask. Let's continue our discussion in the next video. Thank you for watching.